Okay. Hi. So the next problem given in the posted in the group is you have a uniform metal disc of radius r is taken, and out of it a disc of diameter r/2 is cut off. And those who are regularly watching the videos, class videos, all students, you'll know whenever you have this removed portion, removed, chopped off, cut off, we have to use the idea of negative mass. Okay, so for those who are new, you want to get a better idea, you can watch the recordings in the YouTube channel. Check the playlist. So here what we have is you have the full disk. Let's say this radius is r, for example. Okay, so the radius one, it's capital R, mass, let's say it's capital M. And from this, you are removing a disk of diameter r/2. So diameter r/2, the disk is like this. This portion is removed of radius r/4. Diameter is r/2, no, radius is r/4. This portion is removed. Whenever you have removed, you consider it as negative mass. So it is minus m, capital M and small m. Okay. Now, what is the idea? Remember, whenever you remove this portion, what is left off? The left off portion of the disk will look somewhat like this. I'm not able to draw it properly. Kind of like this. This is the remaining portion, but we cannot calculate the center of mass of this. So what do? We consider this as one full disk plus a small disk of negative mass. So when I add these two, it will give me this. So instead of doing this complicated shape, we do two good shapes which we know and we add them. The trick is using negative mass whenever it's removed. Okay. So now this is equivalent to these two pieces. So one full disk, one disk of negative mass. Okay. Obviously, negative mass doesn't exist. It's a mathematical trick we normally use. Very common idea. So now I have two disks. I need to find the center of mass of these two disks. So what do you do when you have external objects? I convert it into point objects by finding its center of mass. So for the full disk, the center of mass is here. So I can assume the entire mass is here. And for the small disk, the center of mass is here. The entire mass is here. I need the coordinates. So as usual, we'll take, okay, let's say this is like this. This is like this. So what we have is this is 0, 0. And this is this distance. You see, this is r/4. So this distance will be 3r/4 because this total distance r. So this is 3r/4. So this is 3r/4, 0. Now it's a normal problem. X center of mass is m1 x1 plus m2 x2 over m1 plus m2. m1 is capital M, x1 is 0 because it's 0, 0. m2 I need to find. We know how to find it. We'll see that this is 3r/4 divided by m and m2. m2, how do you find? Again, if you watch the videos, you know. If it's 1D, we take length and area. 2D, I take area and mass. If it's 3D, volume and mass. So 1D means length and mass, you'll compare. 2D means area and mass. 3D means volume and mass. So here it's area. So full disk, it's pi r square, mass is capital M. For the small disk, it is pi r/4 square and mass is small m. As usual, we'll divide and equate. Again, watch the videos in the playlist to get a clear idea. So if I cancel off, I get this is 16. So this is capital M/16. So the small m, I should write, remember small m is negative, that's very important. So it is minus capital M/16 minus capital M/16. That's all, problem is over. Just need to simplify a bit. So X center of mass is equal to minus, we can cancel. Let's say minus 3mr/16 into 4 divided by 15m/16. So when you cancel, you see what cancels off in the numerator. We have the m going off, 16 going off. Actually, m/16 cancels as a whole. So what I have is minus 3r/15 into 4. Again, 5. So this minus r/20. What does the minus imply? Minus tells me it is on the negative side of the x-axis. Okay, so somewhere here from the center, r/20. Okay, that's all. Hope this is clear. If you want more clarity, watch the videos. If you like the channel, subscribe to it. And if you want to have your doubts cleared, video solutions, just join the Telegram channel. Link in the description. Inform all your friends. See you.